Hi, this is Vignesh. In this video, we're going to learn about exponential growth and exponential decay models, right? Tell whether the function represents exponential growth or exponential decay, right? So we have this exponential function y is equals to e to the power of 3x, and we need to determine if it's an exponential growth or exponential decay. How do we tell if a model is exponential growth or a decay? Let's take our general exponential. Y is equals to a times b to the power of x, right? This is a general exponential model where a represents your initial value and b represents a base, and x is basically an exponent or basically time, right? Like how the function is varying with respect to time, right? So x represents time there. So for an exponential growth model, you want your b value to be greater than 1. Exponential growth is b greater than 1. And if b is less than 1, then it is an exponential decay. What that means is, as the time goes, your model is increasing. So that is b is greater than 1. And as the time is going, if b is less than 1, your value will come down. So that is an exponential decay. So in this problem, y is equals to e to the power of 3x, right? The initial value is 1 because there is nothing in front of your e. So initial value is 1 and b is e cube whole to the power of x, right? So we all know e is approximately 2.71. So 2.71 cube is always going to be greater than 1. So this is, since e cube is going to be greater than 1, right? So therefore this model is an exponential growth model, right? Exponential growth model. Yeah, does that make sense? Cool. Let's go into the next question. Y is equals to e to the power of negative 2x, right? Again, in this problem, the initial value is 1. Y is equals to 1 times e to the power of negative 2, that is your b value, and whole to the power of x. So take a calculator and find e to the power of negative 2. E to the power of negative 2 is approximately 0.135. So e to the power of negative 2 is approximately 0.135. Therefore, this value is less than 1. So as time goes by, your value is coming down. So it is an example for exponential decay. Exponential decay. Cool. Next problem. Y is equals to 2 times e to the power of negative x. If in this problem, the initial value is 2, so you're starting at 2, and b value is e to the power of negative 1, right? Y is equals to 2 times e to the power of negative 1 whole to the power of x. So now your b value is e to the power of negative 1. B value is e to the power of negative 1, which is approximately, let's take a calculator and find that value, e to the power of negative 1. It is approximately 0.367, right? So this is also less than 1. You see, whenever you have this negative exponents like negative x or negative 2x, so most likely it is an exponential decay problem, right? So therefore this is an exponential decay. Cool. Next problem. Y is equals to 3 times e to the power of 2x, right? 3 is your initial value. E to the power of 2 is your b value. So this is 3 times e square whole to the power of x. And e square is obviously going to be greater than 1 because e is approximately 2.71. So therefore this model is exponential growth model. Next question. Y is equals to 0.5 times e to the power of x. Right? So your initial value is 0.5 and your b value is simply e. So 0.5 times e to the power of x. So b value is e, which is definitely greater than 1. Therefore, this model is exponential growth model. Exponential growth. Next problem, y is equals to 0.25 times e to the power of negative 3x. Initial value 0.25 and b value is e to the power of negative 3. So 0.25 times e to the power of negative 3 whole to the power of x. B value is e to the power of negative 3. Find that value. Since we have a negative exponent, it is most likely going to be your exponential decay model. But I'm just going to find that value. E to the power of negative 3 is approximately 0.049. So this is an example for exponential decay. Next problem. Y is equals to 0.4 times e to the power of negative 0.25x. Initial value is the first one 0.4 and b value is e to the power of negative 0.25. B is e to the power of negative 0.25. It is approximately 0.778, which is less than 1. Therefore, this model is exponential decay. Very simple, right? Like you just look at the b value. If b value is greater than 1, exponential growth. B value less than 1, it is exponential decay. There is one more problem in this exercise and then we can wrap this up. Y is equals to 0.6 times e to the power of 0.5x. 0.6 initial value, e to the power of 0.5 is going to be your b value. E to the power of 0.5. So this value is approximately 1.648. The e to the power of 0.5 is nothing but square root of 2.71. So it is slightly greater than 1. So 1.64. And this is greater than 1. Therefore, this model is exponential growth. Right? I hope you understood how to identify exponential growth and exponential decay models. That's all for this video. I will see you in my next video. Bye.